The Personal System 2 is IBM's second generation of personal computers. Released in 1987, it officially replaced the IBM PC, XT, AT and PC convertible. Many of the PS2's inventions, such as the 1.44 MB 3.5-inch diskette drive, 72-pin SIMS, the PS2 port and VGA, went on to become the PC standard. Today we're going to restore one of the 4 models introduced during the release year of the IBM PS2 line. This machine is in a pretty decent condition, but it's quite dirty. That probably doesn't show up too well on camera, because beige boxes like this tend to get overexposed. It does have a couple of small scratches, but nothing too bad. According to the sticker here, it's an 8550-021. To get inside, we need to remove 2 thumb screws at the back here. This machine came untested, and I have never powered it on, so I don't know if it actually works. The serial number is 53042. That is a very low serial number. So this is probably a very early machine. Unfortunately, someone has snatched the cards in this IBM. I'm also noticing that this machine is pretty smelly, so it definitely needs a wash. Inside the lid, there are some dark marks here. Can't say what it is, but it's right above the power supply. So maybe something has popped inside here. I guess we'll have to find out. Oh, the battery is still in this machine. Let's get that thing out as quickly as possible. Well, I can't see any apparent leakage. So if it has leaked, at least it's not much. The battery is still clean. What's that date? Oh, it's a Panasonic, of course. They made some seriously good batteries back then. I have yet to see a leaking Panasonic. I can't see a date, but there are some numbers here. 765. And it's made in Japan. And it even has IBM part numbers. These machines are more or less toolless. So by pushing on a tab underneath the diskette drive, we can just slide it out. And these drives are notorious for going bad. So we are most likely going to repair this drive. And we still have the original hard drive. Now let's hope it works. That would be an awesome find. Just by pushing on these tabs, we can slide the drive out. Well, it's completely filled with dust, so we're not going to power it on quite yet. Next thing to come out is the hard drive controller. And it's stuck down to one of the MCA slots. This machine has an ST506 drive, but the interface is an IBM PS2 Special. Normally you would find a special tool stuck down into this hole, and that tool is for removing these clips. Unfortunately, the tool is missing, so let me go and grab a spare. Okay, I found the tool. So normally it would be stuck down in the case like this. So the way this tool works is that it fits on these clips, and then you just push on them and they will release. And after releasing both clips, you can remove the fan. There's actually a handwritten date code inside the fan here. I'm not 100% sure because it's kind of hard to read, but I think it says 1187. So perhaps my guess is right. The riser card is held with this thingy here. I have never seen one of these, so I'm not sure how to remove it, but I'll just go slow and hopefully I won't break it. Okay, that was easy. So it's some kind of special contraption. Yeah, not sure what to call this thing. And it's actually made out of metal, so it's a bit rusty. Now we can pull the riser card for the diskette drives. We have actually hacked one of these on this channel many years ago to take a standard diskette drive. So we basically soldered regular flat flakes directly to the PCB. This card says, well, I'm not sure, I think that says B887. So maybe week 887. Oh, here's another date. Week 26 of 1987. It's an international power supply made by Gresham Lion. Never heard of those guys. Next we can remove the remaining tabs. Sometimes these get stuck really badly, but on this machine they seem to be quite okay. Moving on to the remaining tabs at the front of this cage. Yeah, these came off really easily compared to the machine I have restored previously. Okay, 7 clips in total. So now we can remove this entire cage here with the speaker attached to it. Underneath the speaker there's one tab here that we can push on to remove the speaker from the main cage. Okay, that took some persuasion, and this machine is just completely filled with dust everywhere. Very smelly dust. Next we have the power supply with a big chunky red power switch. It looks a bit loose, so we need to check this. The power supply is held down with bolt head screws. I don't have a nut driver quite this large. 1 screw at the front and 2 screws at the back. This screw here looks a bit skewed. And sure enough, the I/O shield at the back here is all bent up. So someone dropped this machine. Okay, I think we can remove the power supply now by sliding it sideways. And it makes connection to the PCB with this large connector here. Rather weird and interesting solution. I guess we might as well take care of that I/O shield right away. And we can probably fix it later when we reassemble this machine. Yeah, that screw is really stuck. But I think it's coming out. Yeah, that went okay. On the motherboard we have a few more screws. Look at those bodge wires. They are crawling around on the motherboard. They kind of look like spaghetti. So I had one of these back in the day. Model 50 like this was actually my very first Wintel PC. The I/O shield doesn't seem to come out together with the motherboard. So I think I need to remove these standoffs. It's been 3 or 4 years since I restored one of these. So I can't quite remember. Okay. So I was mistaken. The I/O shield comes off together with the motherboard in one piece. Well, that is pretty disgusting. It's completely filled with nasty green sticky dust. So how about a close-up before I wash this machine? This is what I have to deal with to make YouTube videos. Oh, we might as well remove the lock before I wash all the pieces. The RAM sticks in these machines are held in place with these very fragile plastic clips. So if you don't need to remove them, I'd say leave them in. These clips are very easy to break. This board is filled with these 3-legged tantalum caps. So we know for sure that they are going to blow. But so far I have not seen a PS2 with blown tantalums. So I'm going to leave them in. I find it more interesting to see how many more years they will last, rather than just replacing them. I'll make sure to update you guys when these guys pop. There are some stickers on this chip here and a few more on the board, but the text is completely gone. We'll take a closer look on the board later, but right now this board needs a wash. I think I'm going to remove these BIOS chips before I wash the board to preserve the paper labels. Oh, these are really crusty sockets. Okay, let's find out what was causing all that heat inside the power supply. And this is a T20 security bit. Oh, this screw is actually loose. So, I wonder if someone has been inside here. That is a weird connector. It's actually made out of several pieces. And it has come apart. But we're gonna have to figure this out and reassemble this connector. It probably just snaps into place. Yes, it does. Okay, so that was an easy fix. Now let's see if we can pry this apart. And the usual disclaimer applies. Please don't poke around inside power supplies. They may contain high voltages, even with the cord unplugged. Well, it's dusty and it's smelly, but I can't see anything burnt. And the power switch is loose because this clip here has come undone. So perhaps this machine was dropped or placed with the power switch facing down. That may have bent it out of shape, but that's an easy fix, so no worries. In fact, let's bend it some more and remove that power switch. The power LED is actually glued in place, so I'm gonna have to re-glue it later. The main power connector seems to be held in place with two plastic tabs. Yeah, that was pretty easy to remove. All these wires are soldered, so I'm not sure how this is gonna go. And here's that loose piece. That was actually quite easy to remove. And here we can see some more of that heat. So something got seriously toasty inside this power supply. And the heat seems to be generated from right above this R26. So apparently that is a toasty resistor. Next we have a bunch of screws holding down the PCB. I don't always disassemble power supplies, but this is a smelly one. And I think we have another date here, 1387. I also want to make a thorough inspection and make sure that nothing is burnt inside here. Okay, I think that was the last screw. Almost. Oh, I see something that resembles a reefer cap. That definitely needs to be checked. And I can also see that we have had some liquid in this power supply. I guess this could be flux residue from the factory, but it could also be a cup of coffee. It's a bit hard to tell. Okay, so this was a tricky one. It's not a reefer. This cap here is Vima branded, MP3 series. It looks sort of like a reefer from the side here, but then it's covered in blue paint. I did a Google, of course, and these were also available without that blue paint, and they look almost exactly like reefer caps. So I'm not sure if I should replace it or not. So this is what we'll do. I'll order a spare cap if I don't already have one, and you guys let me know. Should I replace that cap or not? It hasn't blown and I can't see any cracks. So this is one of the leads, so that is actually not a crack. But if it's anything like reefer caps, that thing is definitely gonna blow. I had a look on the inside here and apparently it's an X2 cap. So this is easy to find a replacement. But I don't like to replace parts that aren't broken. That being said, I don't like explosions either. Oh, I found something more interesting here. So this thing here is a very toasty resistor. And this part here is made out of plastic. And it's completely molten from heat. This is not a great power supply. Here it is from a different angle. So look at this piece here. It's just completely molten. That plastic piece is way too close to that resistor. Okay, moving on to the drives. So these drives are known for have a few caps that starts to leak on the lower PCB. And I seriously doubt that this is an exception. Okay, so this is an ALPS drive, DFL 713A, and someone has tried to repair this drive. So there's one screw missing here, and someone has tried to remove these screws with the wrong screwdriver. So I hope I can get them out, because they are in really bad shape. Yeah, look at this mess. That is pretty bad. I'm gonna try to remove them off camera and use as much pressure on the screwdriver as possible. Okay, that was just pure luck. So some of these drives have a very fragile ribbon cable. So I hope that whoever destroyed those screws didn't get far enough inside to mess up that ribbon cable. And here's that ribbon cable. So the trick is to remove the PCB without ripping these cables off. So I'm going to use tweezers and gently pull those ribbon cables off. They are not coming off easily. Let's try with slightly larger tools. Yeah, that went okay. So we're in luck. That ribbon cable still looks okay. Okay, next up we can disconnect this PCB. Another common fault with these drives is that this rubber pad here is glued in place, and that glue dries up. And yeah, sure enough, this piece was just laying on top of the heads here, so that needs to be glued back on. The problem is, when it comes off, it can fall down inside the drive and destroy something else. So if you have a PS2 drive, have a look inside and see if that pad is loose. You don't need to remove the PCB because the pad is coming through the PCB here. So that's a really easy fix. Next we have a few screws underneath the drive. These screws are holding the drive. So with these screws we can remove the drive from the drive cage and access the lower PCB. Okay, I just realized that the microphone was turned off. So what I did was to remove the drive from the cage. And to do so, you have to lift the drive at the front and then pull it out. And this drive was actually really stubborn, but I got it out eventually. So this drive is ready for cleaning and we can move on. I'll do all the cleaning off camera. Okay, moving on to the hard drive. And this 20 meg drive is a VD325N, made in Japan. It looks pretty much filled with dust, so we can't just turn it on. We need to take it apart and clean it. So we have taken one of these apart before on this channel. And that drive was completely messed up. So let's hope this one is in a better condition. I still have the other drive, so I can show you in a moment what the problem was with that drive. Okay, we have 4 screws in the PCB. Then we have ribbon cable that looks very fragile too. So we have a couple of connectors here. So I'm guessing here, but I think we need to remove this ribbon cable here first. Let's try with tweezers. Nope, that's not working. So how about these connectors? Yeah, this one is coming off. Okay, let's see if we can get a smaller connector off. Being very gentle, not to stress that ribbon cable. There is one more connector here. Now I think we can flip the PCB. Or can we? Oh, it's the ground cable. I guess we'll remove it first. Yeah, that definitely needs some cleaning. Okay, so let's see if it's stuck or not. Let's see if it requires any force or make any noises when I try to move it. It did make some noise. Yeah, it does make some noise. Unfortunately. But it moves freely. I'd love to find one of these drives in working condition. Okay, so it seems to unlock by pushing on this piece here. Now we can pull the connector off. Yeah, that is one disgusting PCB. Okay, so this is what we'll do. I'll dry clean this drive and get all of that dust off. And when it's clean enough, we'll open up the lid and have a look inside. Okay, board is washed and dry. I guess we should put the ROMs back in. But first some deoxit magic in those very crusty sockets. And those stickers are barely hanging on. I'm pretty sure these are Rev 0 ROMs. But I am not aware of any advantages of upgrading the BIOS on these boards. There is also Rev 1 available for these boards. Up here we have 1 meg of RAM in these two slots. And down here we have the 286 and an empty 287 socket. I'm gonna leave it empty. The 286 is only running at 10 MHz. So we need to figure out how to overclock these machines. It could be as easy as replacing one of these crystals. But as far as I know, no one has really tried. And over here, by the VGA connector, we have that lovely gold top ceramic InMOS chip. And then we have a bunch of 16-bit MCA slots here. I have checked all the tantalums, and none of them is cracked. So the board is ready to go back into the machine. Okay, next up we have the hard drive. And since it's making funny noises, we're gonna have a look inside. I have removed all the screws, but the lid is stuck on the sticky rubber gasket. So let's gently pry it off. Normally I wouldn't take the lid off a hard drive, because you can get some dust inside. But in this case I think we should. By the way, the hard drive in the 5155 that we opened up to release the heads, that drive is still working. I just played some Tetris on it the other day. Okay, I think the lid is coming off. There are some scratches. Yeah, that surface doesn't feel too good, unfortunately. It's heavily scratched. Crap. I think this drive is shot. Yeah, that doesn't sound too good. Yeah, unfortunately, I think this drive is shot. That's too bad. Not sure how well this show up on camera. The surface on the platter kind of looks like it has some lacquer that is coming off. And it has tons of scratches. If you can hear it, those heads don't sound too good. I don't know what this is, but I'm guessing it's corrosion. Here's the platter of my other drive. Man, this is even worse. When we turned it on, the head started to move. But when they reached this spot here, they got stuck and started to grind away. I found some minor rust in the machine that we are working on. So perhaps this is caused by storage in a damp environment. Okay, let's see if we have better luck with this drive. So the caps on the main PCB, they seem to hold up fine. So we're gonna leave them in. However, the caps on a lower PCB, they are pretty much guaranteed to go bad. So we can't just turn this drive upside down because then we will damage the heads. So I'm going to use a couple of pliers to keep the heads off the board. Before we can remove this cap here, we need to protect this component here. And to do so, I'm going to use a box cutter blade. Some Kapton tape would be very useful here, if I could find it. But at least I went ahead and ordered some more. This is, by the way, a 1 microfarad 50 volt cap. Okay, let's see if that was enough protection. Well, not quite. So the box cutter blade got so hot and actually melted the housing on this component. Well, it looks worse than it is. Only the corner here is melted. So hopefully that component is still good. Well, that Kapton tape better arrive quickly before I damage any more components. This cap here is very close to these wires. So let's move them out of the way. Well, this cap here is actually very close to this component too. And this component too has plastic parts. So maybe I shouldn't use the rework station in these drives. Yeah, let's change tactics. And instead use some Flux and some chip quick. So this stuff stays molten for much longer than usual solder. So that way we can just melt the solder and push on the cap to remove it. This is definitely the way to go with these drives. So those caps were 1 micro 50 volts. But the cap in the middle here is a 10 micro 16 volts. This stuff is great. But it's very important to clean that stuff off, because you don't want to solder with chip quick. So let's add some Flux and good old solder wick. Better clean that Flux off. We better grab this solder ball. Okay, that's clean enough for me. Splash of solder on one of the pads. And now we can add a new cap. Minding the polarity. The polarity is a bit trickier on this cap here, because the marking is hiding away underneath here. And there's actually no marking on top of the cap either. Okay, that was the third and the last cap. So, a quick cleanup. And we can move on to the next issue. And these are now happy caps. Okay, our next issue is the rubber pad. I cleaned it. That old glue was so bad. It actually came up with just IPA. Better smear it so it doesn't drop down onto the head. I better use a diskette so I can push on the pad while it dries. The final step is to lubricate worm shafts. And I'm using PTFE white grease. I'm also going to add some of these rods here. There isn't much needed, so I'm just using a Q-tip. Aside from those moving parts, we also have this rod here. There are some more moving parts inside, but that would require more disassembly. And since everything seems to be working, I think this is enough. Now we can install the drive in the drive cage. Sometimes it's quite tricky because it gets stuck into those rubber pads. So I have to push the drive further down the cage than it has to be able to install the spring for the eject button. Now we can push the drive forward. Making sure that spring doesn't fall out. Like so. Quick tests. And then we can reinstall the screws underneath. I don't know if these connectors are coded, so I took a picture so I can reinstall them the same way they were originally installed. There's also this shield to remember, and then of course these two screws for the PCB. Now to the tricky part, to reinstall the ribbon cables. I added some deoxit to the connector to make it slide a little easier. Oh, this is going to be too difficult to do on camera. Okay, that took some serious effort. So be prepared to spend some time with these ribbon cables if you're restoring one of these drives. I'm obviously not going to reuse original screws, since they were so badly damaged. But luckily I have spare screws. Okay, time for the reassembly. We will do some more tests with the power supply. The I/O shield was really easy to bend back into shape, so we can install it on the motherboard again. Well, I think this power supply needs some more testing. But before we do, let's test the motherboard. To test the motherboard, we're going to use this known good power supply. It doesn't say, but I think this power supply is made by AMTECH. Okay, keyboard, VGA and power connected. Let's see if this motherboard works. I think it does. It's counting up the RAM. And we're obviously getting a bunch of errors. Well, I guess we could test some more things before we move on to the power supply. Testing the diskette drive is a bit tricky without reinstalling the cage. Well, let's see if this works. Looks a bit funny, but I think this may work. So let's insert the reference disk. Okay, it moved ahead. And the motor spins. Sounds like it's reading. Yes, it works. Awesome. So we've got a working diskette drive. We've got a battery error. That is obviously expected, since we don't have a battery installed. Well, this is a good test for now. Now we can move on and test that power supply. Okay, to test that power supply, we're gonna need to do some unboxing here. So full disclosure here, I got this for free from Sabrina at PerGear. They are not sponsoring this video, but I didn't have to pay for it. 2 years warranty, that's not bad. So the reason why I accepted this camera is because I think that I can record whatever temperatures I'm seeing and get them on the video. Man, this thing is tiny. Very generous gift. I think I can use this camera to record the temperatures when we're testing stuff. And that way you guys can see on the screen. So I have no idea how this works, but I'll figure it out. We've got a manual in English, so I'll go ahead and install this and we'll try it out and see what's going on with that power supply. Okay, I actually didn't have to read the manual. It asked me if I wanted to download the app. I said yes. Now we're up and running. I haven't done any settings at all. So I think it's showing the lowest and the highest temperature to wherever I'm pointing the camera. So I've never used one of these before, so I hope this recording isn't too crappy. Yeah, definitely. So I'm getting 24 Celsius up here and 22 on the motherboard. Okay, cool. So let's see what's going on with that power supply. Okay, before we proceed, I'm just gonna have to say, don't do what I'm doing here. There will obviously be high voltages present when I do this test. I have connected the fan, just so I can hear if the board is running. So let's flip that switch and see what's going on here. Okay, the board is running and it's posting. Oh, we're getting some really high temperatures over here. Yeah, that resistor is toasty and it just keeps rising. It seems to stabilize at around 170 Celsius. And then we've got that plastic piece that was melting. It's not as bad. It's at around 70 Celsius. So, is this a design flaw? Or perhaps there is a bad component in this power supply that is causing this resistor to get this hot. We did have some liquid on the PCB, so maybe that was cap juice. I'm gonna leave it on for a few minutes and check the temperature again. And the way this is designed, I can't really see how there would be enough airflow through that resistor to keep it cool. Okay, it's been about 1 minute. And that resistor is stable at 170 Celsius. This resistor is at about the same temperature. That's just way too hot. And that fan is very noisy. Okay, let's try to shed some light on this issue. Let's take a look inside the other power supply. So this power supply is from a machine with serial number 92,000 something. So it's still 1997, but later in the year. And just by looking at it, I can see that it's completely different. It's using a much smaller security bit. So these are T10. Let's see how this comes apart. Yeah, this is a completely different design. And sure enough, that logo I recognized on the power supply is indeed AMTECH. So first of all, the power LED isn't glued in place. Instead, it has its own PCB here. The power switch is a different brand, and these large resistors are still getting toasty by the looks of it, because the PCB is a bit discolored underneath. But these square ceramic resistors are way larger, and the power connector looks quite a bit more sturdy. Well, now that we have a fancy camera, let's see how this power supply behaves. And this time I'm going to remember to turn the camera on. So let's switch the power on and see what happens. Okay, this diode here is heating up quite quickly. And these resistors too. Well, they do get hot, but we're not seeing any 160 degrees at least. 76, 65. I'm obviously skipping ahead here. After 1 minute we are approaching 100 degrees Celsius. So we definitely have some toasty resistors in this power supply too. But this is almost half the temperature. So what do you guys think? Bad design or bad caps? Okay, it's been on for 6 minutes now. And we're just below 100 degrees Celsius. So I'm gonna leave it on for a bit more and do a final check. Okay, it's been about 10 minutes. Our 286 has reached 60 degrees Celsius. And the resistors in the power supply are at 90 degrees and 105 degrees. So yeah, definitely toasty, but nowhere near the other power supply. Okay, time to install the motherboard. A few screws at the back and a couple of screws on the motherboard. By the way, I decided to edit some of the video
And I absolutely love that camera. But what I do, that camera is perfect. And together with the camera, I also got a promo code. So if you're on the market for a camera, you will find a link below this video. Oh, and I'm obviously not going to use the original power supply. I may make a repair video, I'm not sure. Since these clips are prone to fail. Yeah, you can see that crack here. I'm going to add some PTFE. And hopefully they will last a little bit longer. Now we can reinstall the cage. These clips are locked by pushing on them, like so. Pretty nifty machines. Very easy to service. I'm also going to borrow the fan from another machine. I have replaced the fan in this assembly in a previous video a long time ago. So this is not an original IBM fan. Next we have the riser board for the diskette drive, together with that locking thingy. Oh, I just realized we're not going to use this riser card. Instead, we're going to use this hacked board. I hacked this board because I didn't have a working diskette drive. So this card has a regular floppy cable, but that's not why we're using it today. Because this card also have a power connector with a regular Molex. We're going to need it today. Now we can install the original diskette drive. And since the original hard drive is shot, I'm going to install a SCSI controller. And this is why we need a Molex connector for this SCSI drive. The SCSI controller has a Molex connector here, but then I would have to find or build a matching cable. But I want to upload on time instead. We are of course going to use an Apple branded drive in this IBM. Next we have the speaker and the battery holder. And then we need a fresh battery. We are of course going to use the Varta, aren't we? These connectors look a bit dull. Better add some deoxit. And then the battery from hell. Okay, quick test before I put the lid back on. Oh no! It wouldn't start. It just makes some weird noises. And then it shuts itself down. Oh no! Maybe it got pissed off because of that Apple drive and that Varta battery. I know I would, if I was vintage IBM. Well, I guess we need to disconnect a few things and see what might be the problem. Well, this problem kind of reminds me of a shorted tantalum, so maybe I said too much. Okay, let's try again. Whoa, that was weird. Let's see if it posts. Yes, it does. Okay, interesting. So perhaps one of the wires on my hacked board here has come off. Well, I think I did a pretty good job. But who knows? It's squeezed in very, very tightly here. Because there isn't really room for this hack. No, all the wires look okay. Well, let's start by reinstalling the riser card. Try again. No, it's this damn thing that's causing this. Well, none of the wires has come off. So I don't understand why. But I guess we'll skip it for now. Maybe it's not compatible with this motherboard. It's been quite a few years since I did this hack, so I don't really remember all the details. Well, I checked and double checked, and my dodgy hacked board
just isn't compatible with the slightly older motherboard. How bizarre.
Okay, we're in luck. I found the cable.
And finally, it's time to put the lid back on. That is a good looking machine. Maybe I'm a bit biased because of nostalgia, but they are cool, aren't they? Okay, time to flip that switch. And we're getting angry beeps and blue texts. So I need to insert that VGA connector properly. Okay, that's better. Okay, a bunch of errors. Well, that's odd. Now everything is grey. This is supposed to be blue. Okay, so battery error. Let's fix this. And it's running an automatic configuration. An error occurred while loading the file. Try a backup copy. This is odd. I was expecting the background to be red, but it's black. Maybe I'm mistaken. Let me see if I can find a copy of the reference diskette. Okay, fresh copy of the reference disk. Let's boot and see if this works. Well, it's reading. And that old Apple SCSI drive is grinding away. Doesn't sound too good. I'll see if I can find something more suitable for this project. Okay, now the IBM text is blue, as I expected. So why was it grey earlier? I think my VGA cable may be a bit sketchy. Okay, let's proceed and see what happens. This is just a battery error, because we have replaced the battery. Automatic configuration is being run. Fingers crossed. The description file for the adapter in slot 2 was not found. Insert the diskette with the correct file. Well, I was of course prepared for this. That is the SCSI controller. And this is a future domain MCS 350. So if you're new to IBM PS2s, this is sort of like a driver for the SCSI controller. Now we're prompted for the reference disk again. Automatic configuration complete. Now let's see if that SCSI controller pops up on the screen here. It has its own BIOS, so we should see it after the RAM count. Yeah, here it is. Future Domain Corp. SCSI disk drive, ROM BIOS, version 1.0e. The SCSI drive is at address 0, and it's a Quantum LPS 270S. So let's go down to set features, set date and time. Let's see if this is year 2000 compliant. I think it is. Great. I'll remove the diskette. Let's see if it boots to the hard drive. And it does. Awesome. So we have a working system. I think the next step is to test it with a game. Let's try with Monkey Island. The installation went okay. Let's give this a try. Yes, it runs, and the colors are good. So that was probably just a sketchy VGA cable. Well, it runs nicely, but I'm not so sure about the sound. So next week we are going to build up one of these. This is an AdLib clone for one of those weird and wonderful MCA slots in the PS2 machine. If you want to join me in that video, hit the bell icon below and set it to all. That way YouTube will notify you when that video is out. I'd like to end this video by saying thank you to my patrons. Thank you for your support. If you want to become a supporter of this channel too, consider becoming a patron. You can use the link in the description. As a patron you will get early access whenever possible. And now is a good time to watch the video where we restore and repair the IBM PS2 Model 30-286 and this 8515 CRT display that we have been using in this video. Thank you for watching. You can also support me with a like and a comment. If you're a regular viewer, consider subscribing to this channel. And I'll see you guys next week.